Hey there, this video is an introduction to quadratic functions. So first of all, let's review what we already know about linear functions. We know we started with a linear equation, which just had a single variable and it had a single solution. And then what we did was we took the linear equation and we made a linear function, which means we introduced another variable. So this has an infinite set of ordered pairs, and because it's linear, it would form a line. So now think about what we've done so far in class with linear or quadratic equations. We have solved these, and we know that when we solve a quadratic equation, we get 0, 1, or 2 solutions. Well, now we're going to take a quadratic equation and we're going to make a quadratic function out of it. Again, it's an infinite set of ordered pairs. And instead of a line, they're going to form what we call a parabola. So the general form of a quadratic function is y equals ax squared plus bx plus c, or in function notation, you would have an f of x there. But what's important is a, b, and c are real numbers, and a can't be 0, because if a is 0, the squared term drops out, and then we're back to a linear function. Okay, let's look at quadratic functions either have a minimum point or a maximum point. So if the graph opens up, this point right here would be the minimum point. If it opens downward, then this point would be the maximum point. Now let's say you're asked to graph this quadratic function. Well, whenever you graph something and you're not sure what it's going to look like, you make a table. So what we would do is make a table, plot some points, and then draw the curve. So let's see what that looks like. You can see here on the left where I've plotted the points that go along with this function, and to the right here is the smooth curve that's connecting those points. One thing to just note, even though it's not drawn on here, these go on forever. So we need to remember that this is an infinite function as well. So let's talk about a couple characteristics of parabolas. First of all, parabolas are symmetric with respect to a line called the axis of symmetry, or simply called the axis. And the point where the axis intersects the parabola is the vertex. So let's take a look at a graph. You can see here we have the parabola, and as I've mentioned before, it goes on forever. So I'll put the arrows here. Now this line here, this vertical line, this is the axis of symmetry. It acts like a mirror. The equation of this line is x equals -2, because vertical lines always have the form x equals a number. Now this point here is the minimum point of my parabola, and it's called the vertex. The coordinates of this point are -2, -1. Now one thing to notice is that the x-coordinate here will always match this number here, because this line is always going to go through the vertex, so the x values should match. We've already talked about domain and range this year. Remember that the domain is a set of all x values and the range is a set of all y values. Well, for a quadratic, the domain is going to be all real numbers, because you can put any value you want into x for that equation. The range is going to be the set of numbers that come out, and that's going to depend on the vertex and whether the vertex is a max or min. So let's take a look at a problem. Okay, here's the graph of a parabola right here, and it corresponds to this equation. Now remember that the parabola goes on forever. So when you look at this equation, you can put any number you want in for x, and you're going to get a real number for y. That's why the domain would be considered all real numbers. So the domain is all real numbers. Now for the range, we need to take a look and see what y values were used. Now we've done this before, where when we calculate the range, we take a note card or something and come up to the bottom of the graph and then come down from the top. Well, the arrows here mean that it goes on forever. So I can't sandwich that in from the top. But on the bottom, you can see that the graph starts at the y value of -1 and uses everything above. So we would say that the range is a set of all y greater than or equal to -1. Okay, let's look at just a few examples. I've got a parabola here and a parabola here. They both open up, which means they have a minimum point, which we call the vertex. So over here, it looks like the point 0, -3, and here I have the point -5, 4. So that would be the vertex. Now when I look at the axis of symmetry has to be this vertical line here that goes through the vertex. So in this case, it's going to be the line x equals 0, and over here it would be the line x equals -5. Now when we look at the domain and range, we've already talked about the fact that the domain is going to be the set of all real numbers, but let's look at what the range will be. Over here, all of the graph takes place above the number -3 on the y-axis. And then over here, looks like they are all greater than a +4. So we would say that the domain is the real numbers for both of them, and then the range would be the numbers greater than or equal to -3 for this one, and greater than or equal to 4 for this one. Okay, let's look at these last two. I see here that I have a vertex at -2, -1, and here I have a vertex at 5, 2. Then when I look at the axis of symmetry, for this graph, the axis of symmetry is going to be right here. It's the line x equals -2, and over here it would be the line x equals 5. And then when we look at domain and range, we know that the domain is the set of all real numbers. And for the range, now we've got a max, so my entire graph is below the y value of -1 here, and it's below the y value of 2 here. So we would say that the range for this one is y less than or equal to -1 and y less than or equal to 2.